Hello friends, and welcome to this episode of our military analysis program. Today, we are opening the file on the Iranian-made 3rd Khordad air defense system. This system is in the medium-range class and plays a significant role in air defense. Our goal is to examine its technical specifications, field performance, and of course, the drawbacks of this system. The 3rd Khordad is an indigenous air defense system designed in Iran. This project was initiated to replace older systems and reduce reliance on foreign sources. The domestic production of all components guarantees Iran's access to the supply chain. This system was first unveiled as an achievement in 2014. The general structure of this system is built upon a wheeled chassis with high mobility. In modern warfare, being static equals death, and mobility increases the chance of survival. The radar, missiles, and fire control system are all integrated onto a single vehicle. This feature allows the system to fire quickly and immediately leave the area. The radar of this system is of the active phased array type, which is considered up-to-date technology. This radar can send waves to different points in the sky without mechanical movement. Precision in tracking targets and high scanning speed are characteristics of this type of radar. However, its detection and engagement range is more limited compared to strategic systems. This system has the ability to engage 4 targets simultaneously and guide 8 missiles. This figure is adequate for medium-intensity conflicts, but is not sufficient during heavy attacks. If the number of enemy targets exceeds 4, the system will become saturated. This is one of the inherent limitations of single-vehicle tactical systems on the battlefield. The main missiles of this system are the Tayir and Sayyad families, which are produced in Iran. These missiles bear similarities to standard models, but have undergone modifications. The engagement range in early versions was 50 to 75 kilometers, which has since been increased. Newer versions claim to reach longer ranges of up to 200 kilometers. The turning point of this system's performance was the hunting of the Global Hawk drone in 2019. This event demonstrated that the radar has the ability to detect targets with a low radar cross-section. Additionally, the missile was able to reach an altitude exceeding 50,000 feet and function effectively. This was a successful operational test, but it should not necessarily be generalized to all conditions. One technical feature is the fire and forget capability in some versions. This means the missile becomes self-sufficient in the final phase, freeing up the ground radar. This capability increases the rate of fire and reduces the risk to the crew. However, the precision of this system against advanced enemy electronic warfare remains a subject of debate. Let's discuss the radar limitations and blind spots of this system. Every ground-based radar is limited to the horizon, and the curvature of the Earth blocks its view. This system has a weakness against cruise missiles approaching at very low altitudes. Unless it is connected to a larger radar network to receive information, it remains vulnerable to low-level threats. Another flaw of this system is its potential vulnerability to anti-radiation missile attacks. Although mobility is high, activating the radar reveals its location. In a battle with a country possessing a powerful air force, the survival of this system is difficult. The need for camouflage and remaining silent until the last moment is its primary survival tactic. Regarding the engagement altitude, this system can cover up to 30 kilometers. This altitude is perfectly suitable for hitting most fighter jets and reconnaissance drones. However, this system does not have the ability to counter ballistic missiles that exit the atmosphere. The 3rd Khordad is designed for aerodynamic targets and is not a complete anti-missile shield. Iran has attempted to create a naval application by installing this system on vessels. This is a creative measure, but involves challenges regarding stability and corrosion at sea. Using a land-based system at sea involves complex software and hardware modifications. It is not yet clear if its performance on water is as precise as it is on land. Compared to systems like the S-300 or Patriot, this is a mid-range system. Its range and processing power are not comparable to the global giants of air defense. However, its advantage lies in its low cost and high quantity within Iran's defense network. Sometimes, quantity and dispersion can compensate for weaknesses in quality and technology. One of the major challenges is countering electronic warfare and heavy enemy jamming. Phased array radars have good resistance, but no system is completely immune. In an environment with intense electronic warfare, the target detection range drops drastically. This is a reality that Iranian engineers must continuously work on. The missile guidance system in the mid-course phase is usually carried out via a data link. If the radio communication between the missile and the system is severed, the missile will go off course. Maintaining the stability of this data link in real combat conditions is vital and difficult. Success in tests does not necessarily guarantee success in all-out war. Another positive point is the operational independence of each firing unit on the battlefield. If the integrated defense network is severed, the 3rd Khordad can operate independently. This decentralized feature makes the complete destruction of the defense system difficult for the enemy. Each launcher vehicle alone can be a threat to attacking aircraft. Repair and maintenance of this system is low cost and fast due to the indigenous nature of the parts. Iran has no concerns regarding spare parts for this specific system. This issue ensures the operational readiness of the system remains at a high level. In wars of attrition, easy logistics and support are considered a winning card. Iranian developers claim the radar has the ability to detect stealth targets. The hunting of the Global Hawk drone proved this claim to some extent, but not completely. Fifth-generation fighter jets possess much more complex stealth capabilities than drones. The performance of the 3rd Khordad against the F-35 remains a big question mark. Overall, the 3rd Khordad is an important link between short-range and long-range air defense. This system covers the middle layer of the sky and complements other systems. Its design demonstrates the Iranian engineers' correct understanding of regional aerial threats. However, one should not expect this system to perform miracles on its own. The technology used in this system has become a model for other defense products. Experiences gained from it are seen in newer systems like the Bavar 373. Its evolution process shows that Iran is learning and fixing defects. However, a technological gap with superpowers still exists in certain areas. In the end, the 3rd Khordad is a functional, cost-effective, and respectable system. This system has proven to be a serious threat to unmanned aircraft. The existence of drawbacks alongside advantages is a natural part of any engineering system. What matters is how the operator makes the best use of the available tools. Thank you for staying with us until the end of this technical and realistic review. We tried to analyze the facts and capabilities of this Iranian system thoroughly. Write your opinions about the performance of this system in the comments section. Until the next video and the review of another military topic, goodbye.